Okay, so in this video we're going to look at composing two functions when you want not at a specific value, you want the composition just for any x. So this could look like them saying just find f composed with g, or they could say f composed with g of x. Okay, those same thing. Um, so in order to find f composed with g of x in general, I'm going to do it for these two functions right here to kind of show you an example. Um, what you're doing, right, is the x goes into g first, then you take the output, the y value from that, and plug it into f. So how we write that is we're doing f of the y value goes into to f. Okay, so the y value of g goes into f like that. Okay, so g we do g of x, get a y value, then plug it into f. Okay. So what is g of x in this situation? We just look at our function here. G of x is 2x plus 1. So that is how we get the y value that's right here. Okay, so we just plug that in. Okay, g of x is 2x plus 1, so we get f of 2x plus 1. Okay, and then what does it mean when we write this? We're just replacing whatever x is with what is in here, right? That is the placeholder for x. So everywhere there's an x in this function here, x squared plus 7, that's f, we replace it with this 2x plus 1. Okay, so there's an x right there. Replace that x with 2x plus 1. It's going to be squared and then plus 7. Okay. Now, in the book, they would probably distribute out this in the end to get the final answer. I don't necessarily care if you leave it like this. That's just fine. Go ahead and I'm just going to multiply it out just for kicks and giggles. But what we're going to get is 2x times 2x, so 4x squared, okay? And then we're going to get a 2x times a 1 would give us 2x. But then we get another one of those, so another 2x would give us 4x. And then 1 times 1 would be 1 plus 7. So altogether we'd get like 4x squared plus 4x plus 8. Okay, we just got this part by distributing out the 2x plus 1 squared. You could FOIL that out if you wanted to, or you can just kind of remember the pattern of how we square binomials. Okay, that's f composed with g of x. Okay. We could do a similar thing for g composed with f. I'll maybe do that one too, just so that you get a little bit more practice with this. Or should I go real crazy? I'm going to go real crazy. How about this? Instead of doing f and g together, I'm going to do f and f together. How about that? Because I think there's some on the homework where you have to do that. F composed with f. Okay, so what does that mean? Well, the x goes into f first, then you take that output and plug it into f again. Okay, so that's kind of what we're dealing with here. So we first figure out what's f of x, this inside part here. Okay, f of x is x squared plus 7. So let's put it in. Just put that in there. Okay. And then we want to do f of this. Remember this part in here is what we replace x with, right? So everywhere there's an x in f of x, which is x squared plus 7, replace the x with x squared plus 7, okay? So there's an x in this x squared, so replace that with x squared plus 7, okay? And then plus 7, okay? So x squared plus 7 squared plus 7. That's f composed with f, okay? And again, you could distribute out this perfect square here if you want to. You don't necessarily have to. I guess I will just make things better for you. X squared times x squared is x to the fourth, and then we have 7x squared, and another 7x squared would give me 14x squared, and then 7 times 7 is 49. Okay. So x to the fourth plus 14x squared plus, so 49 plus 7 is 56. Okay. That would be your answer there. If it's too messy, I wouldn't distribute it out, but if it's like a square, you could do that. If it's a cube or anything higher, I wouldn't distribute it out, okay? Okay. Awesome blossom. Well, I'll see you in the next video.